Working. Okay, folks, it's 9:30. Welcome to the BESS working group. I just let people get settled. I'm Matthew Bocci. Mankamana sitting with me is our working group secretary. Stefan, I think Stefan is online, who's the other chair. Okay, this is the notes well. Basically, it's saying anything you say here is considered a contribution to the IETF. I'll just leave it up for a moment for you to ponder. One other thing while we're on these sort of procedures, please remember to wear your masks in the meeting room unless you are actively eating, drinking, or speaking at the mic. Right, so this is our agenda. It's a fairly busy agenda. We've got a few minutes slack. I just wanted to note that, as some of you may be aware, today is Remembrance Day, and it's marked in the UK and many other countries by 2 minutes silence at 11 a.m. So there was a discussion on the working group chairs list about how to handle this, and we have a little bit of slack, and it conveniently, if we keep to time, fits on our agenda. So we will, if folks don't mind, observe 2 minutes silence at 11 a.m. Any other comments or questions about the agenda? Okay, so status update. We don't have any new RFCs. We have a couple of RFCs still in the, a couple of documents in the RFC editor's queue. They are both waiting on misrefs. We have, I think, a few drafts with Andrew or in IESG review. That's the IRB multicast draft, the EVPN LSP ping draft, the EVPN PrefDF draft, which is just sitting at publication requested at the moment. The virtual Ethernet segment draft, which is in AD follower. I think Andrew's following that up at the moment. The VPW, EVPN VPWS FXC draft has just had publication requested. And the EVPN aggregation label draft is with Andrew. Okay, we've got quite a few documents under Shepherd's review. We had a big queue of working group last calls done over the last year or so, and this is unfortunately backed up a bit. So I think, Mankamana, you've done a review of the EVPN redundant multicast source draft. It's waiting for, is that still waiting for write-up?
Yes, I'll be sending it after the Friday.
Okay. The EVPN multi-homing PA draft, I think Stefan has provided a review for that. It's waiting. Stefan, are you waiting for anything else on that before you do your write-up?
No, I think it is okay now because I requested the authors to reduce the number of authors on the document, and this has been done. So I think the next step now will be to request the routing directorate review as part of the new process. This is the only missing piece before moving to IESG.
Thank you. The EVPN Geneva draft is waiting for me to do my Shepherd's review and write-up. There's a kind of a, I don't really call it a companion draft, but there's another draft in the NVO3 working group which is describing the applicability of EVPN to Geneva. Yeah, one reminder, can you use the on-site tool and remember to register your presence for the blue sheets up on the, using the QR code. So if you wish to get in the mic queue, use get in the mic queue on using your phone, please. Right. Okay, look, Andre, did you?
For the next one.
The next one. Okay. The FastDF recovery draft is waiting for a Shepherd's write-up for me. I did send a comment to the authors, which I haven't seen a response yet, about whether this updates RFC 85.
Yeah, so Luc-André Cisco, we have received that, and we are analyzing that that request to see how much we need to look at 8584 and see how much it really updates.
Okay.
Yeah, to flag it as an update.
Thank you. The unequal load balancing draft is waiting for write-up from Stefan. The SD-WAN usage draft just went through working group last call, but there is a routing area directorate review of that draft, which we're still waiting for the authors to look at the comments. I think they were fairly minor comments, to be honest. And just a reminder that we will be sending all drafts through routing area directorate review from now on the request of our AD. So when we do a working group last call, we'll do that. We've been typically doing that anyway, but we'll make sure that we do absolutely all of them.
We have 2 people.
Yeah. Sasha, do you want to say something? I think you're in the
Sasha Weinstein, Ribbon. I would like to understand what happens with the EVPN Young. It appears as one of the objectives in the charter. The draft has expired, there is a work group document that has expired 4 years ago. I have sent a few emails to the authors, to the group, to the chairs, asking whether this work has been knowingly dropped, or if not, whether it is going to be resumed, and I haven't got any responses whatsoever.
Okay, so if I can answer that question. So there was a kind of a consensus call that we did, I think just over a year ago, about what to do with the Young drafts, because they weren't being progressed actively at the time, and we had a lot of other protocol documents to deal with then. So they were parked. Should say they're parked working group drafts, I think, on the tracker. If it doesn't, we need to fix that. But if there's somebody who is able to pick them up and run with them, that would be good.
Yeah, at some point there was also we had to wait for some dependencies for other Yang models in other working groups. So for instance, the BGP one, and so on, that were not ready at that time. So there was no way to really progress this document until the other ones were closed.
But is it going to be resurrected and progressed at some time, or is it just going to be dropped?
Of course, no, it's not. It's absolutely not cancelled. So I would say it will be up to the working group to decide when to resume it. It's perfectly fine to go ahead with the documents if we are now ready, and if we have completely cleared the dependencies that we have with the other Yang models.
Okay, because this is something that, from my point of view, is needed, and we don't know. My colleagues and I don't know what to look for and what to expect. Thank you.
Okay, the EVP and ISID CMAC flash draft is waiting for a write-up from me. So I think you're waiting in the queue for the other draft, right? So the EVP and IPVPN interworking draft, so that is still in a kind of an extended last call at the moment, because we had a review from the IDR working group, and the chairs had some comments on that draft. So go ahead.
This is the feedback the BESS chairs suggest I provided this at this time. My review of this found 3 things. It goes against an RFC 4456 requirement for full distribution routes with route reflectors. This can be simply noted as we've discussed it with the BESS chairs and find that the topology in a walled garden works against it. It also specifies a transitive path attribute, dpath, without an open capability limitation, and specifies changes to RFC 4271 without an open capability limitation. The last 2 are could break I understand the word could, not must, break the BGP route selection in a modified 4270 in the case of a partial deployment. That breakage could cause loose and inconsistent in its current. So the IDR chairs are concerned about the approval of DPath and the 4270 changes without an open capability. We realize at this time there are walled gardens or AKA constrained domains in VPN, but past experiences with BGP lead us to believe that BGP updates can escape walled gardens and cause harm to the internet. And perhaps some of you know of incidents where this occurred. Again, we think that there are some things, because it is a deployed topology, where configuration can help that. We look to continue this discussion with the chairs and with the authors. I want to thank Stefan and Jorge for their great interaction on this.
Okay.
Jorge Rabadán, Nokia. Yeah, so I just wanted to say that, first of all, thank you, Sue, for the thorough review and all the interaction as well. And yeah, we are discussing among the authors. Our understanding is based on Sue's review is that the blocking issue right now is to provide some solution to avoid the leakage of this DPath attribute into SAFI1 routes, to avoid basically the potential issues that Sue was referring to. So that's our understanding, and we'll work with that in mind.
Okay. Thank you. Okay, we also have the MH split horizon draft, I think, still in working group last call. Right, the EVPN SR P2MP draft we think is ready for working group last call. It's in our queue. If there's any other working group documents that the authors think are ready and we haven't listed them, please raise that to the chairs. Okay, we have quite a few expired working group documents, but we have a few non-expired working group documents which are currently being updated. Some of these are being presented on the agenda today. I think generally we would probably like to see a higher proportion of the agenda talking about how we're progressing the existing working group documents that we have. We have BESS seems to have a lot of, it's actually very healthy that we have a lot of new work coming into the working group. But we do have a lot of drafts that they're in a fairly mature state that we probably need to move forward and would like to get some updates maybe at the next IETF from the editors of those drafts. Okay, any other comments on the working group status? I think we have Luc Andres on next.
Good morning. My name is Luc-André Burdet from Cisco, and I'll be presenting updates on two working group drafts. The first one is RFC 7432-BESS. So this is the update to the base 7432 draft that we've been using in BESS for EVPN. This latest version has actually a fairly significant update, both editorial and towards content. So I thank both Sasha and Marek for their comments. Thank you. And we did quite a bit of rework to include content from other drafts in the working group to have them be part of the new base 7432-BESS. Next slide. So the changes from 03, so I did not present the changes in 04, but since 03, this draft now effectively creates in the ESI extended community label field a IANA or request an IANA registry for this field. Previously, this field was effectively just defining the no flag present being all active load balancing mode. And 7432, the base, defines the single active mode with one flag. But we found through, I forget which draft, maybe PrefDF or I forget which draft, but we found that updating this ESI field led to some collisions. So effectively, this draft now defines an IENA registry for allocating fields or bits in this flags field. The best paths sections were updated, both from the default gateway, which was in 10.1.1. So they were taken from a best path draft that existed in BESS to clearly define or clearly order the best path selection for EVPN routes. And the section currently covers routes 1 to 3. And there was some question on the usage of the label 2 field, which is effectively not defined. The usage of the label 2 field was not defined in the draft. And so there's a reference to 9135 that is added to the draft now. And apart from that, just many comments and significant editorial changes between 04 and 05, actually. The next steps for this draft on the next slide are we have received many reviews, many comments since it was first published. And even when it was first published, the 00 version of the draft actually was based on a plethora of comments on the base draft, base 7432. So obviously more reviews and more comments are always welcome, but this draft is nearing working group last call stage. So I think we will be ready to seek last call on this draft.
Just a comment, Luke. I think, if I'm not mistaken, you requested some early allocation of cut point, no?
Yes, so I sent that email to Ayana, and I think I CC'd either you or, yeah.
Yes, so I did a poll to the working group to see if there was anyone against the early allocation, and it was okay. So I requested the approval to Andrew, but I haven't received the feedback yet. So I will try to poll Andrew again to give his approval before moving to Ayana. Okay.
Perfect. Thank you, Stefan. The next draft I'm presenting, if there are no other questions, is the EVPN multi-homing for layer 2 gateway protocols. So this is the one that Stefan mentioned in one of his slides for active working group documents. So we refreshed it. Specifically in our case, this EVPN multi-homing attributes registry that we just went over. So now there's a new load balancing mode defined. And instead of just allocating a bit, we now allocate an entry in this load balancing registry or multi-homing attribute registry. There was some comments received based on clarifying the ARP procedures in the draft. And so the version, actually, I think it's not 02, but the version that's currently active, I made updates to explicitly reference 9135, so the IRB-based ARP probing procedures. But I have spoken to the person who made those comments, to Sasha, actually. And he was actually seeking a reference to both our probing scenarios, right? The IRB and the non-IRB scenario. So I will include that use case of non-IRB in the next update and define the ARP probing procedures for non-IRB. So other than that, on the next slide, this draft has matured quite a bit. We have received reviews and comments from many vendors and operators, actually. So there are implementations of this draft. It is in use, so we would be seeking working group last call on it. Are there any questions or comments?
Okay, I don't see anyone in the queue, so I think we're good.
Okay,
thank you.
Thank you.
So next up is Patrice.
Good morning. My name is Patrice Brisset, Cisco. I'm here to talk about the EVPN Layer 3 multi-homing load balancing. This is a draft that came out about more than a year ago, and So what we decided to do here is to bring more collaboration with Jorge and Wen for the other from Juniper and Nokia. So I know for time's constraint, I may not go through all the whole things, but I think what is really important is that people start looking at it. I think it's a very good draft that explained very well how the mechanics and how that works. So can we go to the next slide, please? All right. So basically, what we are trying to achieve is it's exactly what we have been designing for a while in EVPN, but over L3 interface. So you will see that we are taking care of unicast, multicast, and a few of the IGP stuff. Please, next slide. So so the mechanic also is you will see that whenever you're going to read the draft is like we need also to make sure that whenever the synchronization is happening, we can refer to the right interface, the right L3 interface. So all the mechanics has been described there. So in the new version, we put a bunch of clarification to help the readers to understand how this is working. I think with Jorge and Wen, we've done a very good job on that. Please, next. This is pretty much the RUP type that are affected and the use case that we are covering. Next one. And the beauty about this one is the entire mechanics already exists. So, so it's just pretty much explaining how we use current mechanics to and get applied for L3 interfaces. Next. Yeah, obviously we have a bunch of advantages with that because what it means then we are kind of going away from direct ICN link and the whole legacy mechanic. At Cisco, we do have already this solution being run on customers. So, all right, next, please. So please read it, provide feedback, and we're gonna move ahead of that. That's it. Thank you.
Thanks. Any comments? I don't see anyone in the online queue. No. Thank you. Okay, I think you're next.
Okay, yeah, I have short review of 3 drafts here. The first one is the EVPN VPWS Gateway 01, presenting this on behalf of my friends from Nokia, Juniper, and Cisco. We presented this draft 2 IETFs ago, and I think now it's much more stable and better. Next slide, please. Yeah, I'm going to talk about a short refresh, changes that we've made in version 01 and next steps. Next slide, please. The draft in the introduction talks about different ways of having interconnectivity across domains for EVPN, VPWS services. It talks about 3 different solutions, which are all perfectly valid, and depending on the requirements, you should go to one or the other. But if you have the requirements that are listed here in this table, probably the best solution is this service interworking spec that we're specifying here. And there was nothing about it in the BESS working group, so that's why we needed to produce this document. Next slide, please. So the draft is basically all about making the border routers across, connecting different domains, making them service gateways. And in the draft, we talk about redistribution of the routes, of the AD per EVI routes. And even though, redistribution may mean different things for different people. So it's good to understand what it means in this draft in the context of this document. So what we mean by that is when we receive on a border router or a service gateway, we receive an AD per EVI route. We process it according to the existing RFC 8214. We also understand now the DPath attribute along with these routes as per the DPath draft that I'm referring here in point A. We also need to program the forwarding path based on the received route and also based on the encapsulation of the next domain. And finally, we need to re-advertise the route to a different domain. This re-advertisement is really a re-origination of the route, meaning that we can translate, rewrite the route distinguishers, the Ethernet tag, and many other attributes in the route. Next slide, please. As far as the redundancy is concerned, we define two ways of doing it. So the first one here on the left-hand side is what we call the Anycast gateways redundancy. And this is all about configuring exactly in the same way the service gateways that are connecting to given domains, right? So when they redistribute the routes, they will do it with the same route distinguisher, the same Ethernet tag and everything. So the next border routers or the PEs, they rely on BGP best path selection to pick up one of the service gateways. The second way is a bit more sophisticated. It's illustrated on the right-hand side. And here, basically, each pair or all the redundant service gateways that are connecting two given domains, they are attached to what we call an interconnect Ethernet segment. The interconnect Ethernet segment is defined in RFC 9014 for ELAN services. Here we are repurposing the same concept for EVPN VPWS services. But other than that, you have all the beauties of EVPN multi-homing. So you can define the Ethernet segment as single active, all active. You have all the DF election mechanisms, etc. Next slide, please. So the changes that we made in this revision pretty much are these two. We added support for FXC services. So you can also do this FXC services across different domains. We updated references and some other minor details. Next slide, please. So we already presented this draft. It's pretty much stable, and we believe it's ready to working group adoption. So we would like to request that. Any questions?
I don't see anyone in the queue. Thanks.
Okay. All right, next one is the VPN DPath draft. Again, presenting on behalf of my friends from Nokia, Cisco, and Juniper. Next slide, please. I'll talk about a short refresh, what's new in this version, and next steps. Next slide, please. Yeah, so what we are doing here with this draft is we take the DPath attribute that we talked about before. That is defining the EVPN, IPVPN interworking draft. Initially, the attribute was only for layer 3 routes, route type 5 in EVPN or IPVPN routes. Here we are using it for layer 2 EVPN routes, right? And we want to use DPath for two purposes here. To provide some loop detection and therefore protection as well, specifically on service gateways that are following RFC 9014. But we also want to use it so that the PEs receiving the EVPN layer 2 routes can see the DPath and trace all the gateways through which the route has gone. And there is also, we use it in case the DPath has different length, we also use it for modifying the best path selection for EVPN layer 2 routes. Next slide, please. A simple example would be what you have here in the diagram. Let's say you have two data center gateways interconnecting two domains, and they are attached to the same broadcast domain. So the two data center gateway, they receive a given MAC IP route from a PE. They redistribute that route into the other domain. And of course, the two redundant data center gateways, they receive each other's routes. But the nice thing now is that when they redistribute into the other domain, they slap the dpath with the identifier of the domain of origin. So now, for instance, data center gateway 1, when it receives the MAC route, identifies that it's coming from domain 1.1, which is a locally configured domain. So it can actually decide not to install the route because it has a better route coming directly from the PE. Now, the other advantage of this model is, for whatever reason, if data center gateway 1 loses the route coming directly from the PE, it has already another route that is actually advertised from data center gateway 2, so it can do this U-turn thing and provide fast convergence for in-flight packets. Next slide, please. Another example that we have in the draft is for IMET routes or for inclusive multicast Ethernet tag routes or routes type 3. Same thing, you have gateways interconnecting domains for in the same broadcast domain. So they both exchange IMET routes in different domains. So normally you would need to avoid somehow manually to avoid the two parallel links to be created in both domains to avoid packet duplication. dpath provides an automated way to do that. Basically, you would tag the IMET routes in one of the domains with a dpath domain, and that would be enough for the gateways to modify the best path selection and pick up only one. Next slide, please. So what is new in this version 02? Basically, we modified this section about best path selection for routes type 1, 2, and 3. Now it's aligned with 7432-BESS that Luke was talking about before. We only modified that section of 7432-BESS in this draft with including dpath for the best path selection of these EVPN layer 2 routes. We are also clarifying what happens if you have on the service gateways that are following the 9014 procedures and they have interconnect Ethernet segments, how you deal with the ESI and the dpath, because both could be used to detect loops. So we are clarifying that in the draft, and some other minor changes. Next slide, please. Again, so this is version 02. We've presented this several times, so we believe it's ready for working group adoption. But of course, in the meantime, we welcome any feedback.
Sue, I think you're. Thank you.
Jorge, thank you for the nice presentation. Do I understand the draft correctly that all of the changes that you're suggesting are within a single AS?
It's independent, I would say, in the same way that RFC 9014 does not specify if the gateways are connecting domains within the same AS or not.
I would suggest my same comments from the dpath. If you're in a single domain, you need to put an exception for the route reflectors if you're not maintaining the same consistency. If you're between domains, you should explain what the error handling is there. Just as, and if I'm unclear, I can take it offline. Or if you want me to answer it here, I can.
Yeah, we can certainly do that. My only comment would be that RFC 9014 is one example that is already in RFC, and that sentence was not written there, right? But yeah, we can do that if it helps.
I would suggest that addition. I would suggest 9014-BESS, but let's just go on and suggest it for the future.
And also there are some other documents following kind of the same architecture. So
let's agree to disagree on the past and go forward. If that's my suggestion going forward.
Sounds good. Thank you.
Any other questions?
Okay, so one more. This is about multicast forwarding for EVPN to EVPN gateways or eggs. This is a new work. It's pretty much based on some gaps that we identified in the different EVPN multicast drafts. So I'm presenting this on behalf of a bunch of people from Nokia, Arista, and Juniper. Next slide, please. So I'll talk about introduction, some procedures, and next steps. Next slide, please. All right, so why are we doing this? There are two parts. And again, we'll be talking here about service gateways. And what I mean by that is you have multiple domains and you have service gateways interconnecting those domains. It can be for layer 2 services or layer 3 services. Let's talk about layer 2 services first. So we know that we have RFC 9251 that is defining IGMP MLD proxy in the context of EVPN in a single EVPN broadcast domain. We also have 9014, which is defining the service gateway connectivity for unicast and for BUM traffic, but not for IP multicast. Because of that, basically, the question that came up is how do we interconnect two or more EVPN domains with gateways following 9014 when the P's in the domains basically support the IGMP MLD proxy VPN procedures, right? That was not defined anywhere, so we needed a place to do it. Similarly, for layer 3, we have the EVPN IPVPN interworking draft, which defines service gateways capabilities for IP unicast traffic. We also have the OISM draft, or the IRB multicast draft, that is defining how to bridge and route multicast with EVPN procedures. That draft is actually defining service gateways between OISM and PIM, or MVPN. But the question is, we are missing a place where we specify what happens if you have two EVPN layer 3 domains and you want to forward IP multicast between them. That was not specified anywhere. As a result of that, we thought it was needed this, we needed this document. So next slide, please. So the document has two distinct parts. So one for layer 2, another one for layer 3. So if we talk about layer 2 first, the diagram is an illustration that is also included in the draft. And you can see that there are two EVPN domains, right? All the P's and gateways are attached to the same broadcast domain, right? The gateways in between, they are connecting those two EVPN domains. Here in the example, we have, we assume that one domain is using VX9 encapsulation and the other one is MPLS or SRMPLS, but any other two encapsulations would be also valid. So what we are doing here is we assume that the gateways are following the RFC 9014 procedures for unicast and BUM, including the interconnected Ethernet segment. What we are extending here is that now the gateways, they import the SMET routes or the selective multicast Ethernet tag routes coming from the PEs, and they perform what we call a proxy function of those SMET routes, right? When you use redundancy, in the interconnected Ethernet segment, there is a DF and a non-DF. So we mandate a DF to do the proxy function of the SMET routes. There is an option too, if you wanted to provide a faster convergence in case of a failure, there's an option for the non-DF to also do the proxy function of the SMET routes. That is also allowed. And when you do that, basically, there's a risk of a control plane loop for the SMET routes between the redundant gateways. That's why we also introduce the DPath for the SMET routes. In the data plane, there are no extensions here. So basically, the non-DF will block the ingress and egress multicast as per the RFC 9014. And the draft also supports local receivers and sources on the service gateways. Next slide, please. Similar thing, but now the service gateways are layer 3, so you have an IP VERF instantiated. It follows pretty much the procedures of the OISM draft. The only extensions here is that since there are 2 OISM domains, the draft talks or explains the procedures using 2 SBDs instead of 1 SBD. The SBD is the supplementary broadcast domain that is defined in the OISM draft, only that here we are using 2 per IP VERF. Now, it's important to mention that the draft also says that if the gateways are able to perform all the procedures with a single SBD, in other words, if the behavior on the wires is the same as the ones explained in the draft, if the implementation uses only 1 SBD, that's perfectly compliant with the draft. There is also here, we define one more flag for the multicast extended communities that is exchanged by the gateways on the IMET routes for the SBD. And based on that, there is a DR election or a designated router election. So the DR in this context is the one in charge of doing the proxy function, similar to the layer 2 case for the SMET routes between domains. Yeah, we also support here local receivers and sources on the service gateways. Next slide, please. It's a first version, so of course we are very interested in feedback from the working group. And that's it. Any questions? All right, thank you.
Okay, thank you. Greg, I think you're next.
Hello, I'm presenting on behalf of my co-authors. So this is an update to our draft on advertising applicability of SBFD in multi-homed PE domain and for inter-area. Next slide, please. Okay, so I was invited and I was happy to join as a co-author, and we worked and updated scenario descriptions. Next slide, please. So the BFD is a well-known and established method of fast detection of faults, but it does bear some extra operational work that requires provisioning of BFD sessions. SBFD overcomes some of these operational aspects, but just to simplify it, does require their information about the IP address of their reflector, SBFD reflector, and the discriminator that this reflector allocates for SBFD session or sessions. The RFCs already established extensions to IGP for systems to advertise their SBFD discriminators. So this document extends this functionality into BGP. Next slide. For inter and intra-area scenario. So this is scenario 1. So as you can see, so the idea is that you have a service CE double homed with their service PEs, and then their set of access PEs. The idea is that service PE advertises its BFD discriminator so that access PEs can monitor this SRv6 locator. Any questions about this scenario? Okay, next slide, please. Scenario 2 is similar. Again, we have double-homed service C, and then service PEs advertise as BFD extension with the discriminator and the source IP address. And so the access PEs can monitor their status of their connection and the PE. Because understandably, in SBFD, you cannot differentiate whether it's a path failure or node failure. So you need to have integral view and basically fall over and then separately do fault localization and restoration. But at least because it's a redundancy, so there is this architecture allows you for the fast detection and fast failover. Next slide, please. So what's being used? The BFD discriminator that is defined in RFC 9026. So this was case for point-to-point BFD mode. So in this document, we propose two new values for BFD mode parameter. One of them is to detect a SRv6 locator prefix, and another one is to next hop locator. In both cases, optional TLV carries the source IP address so that the receiver of this path attribute can understand what case is being tested. And next slide, please. So here's basically what each of the actors in this process does. So as BFD reflector uses BFD discriminator attribute to advertise my discriminator value and IP source address TLV to advertise is address. So the expected as BFD initiator upon receiving BFD discriminator path attribute can analyze whether it's a type 1 or it's type 2 user scenario and starts sending periodic BFD control messages so that when they're in our case, service P receives it, it sends it back, and so their access P is capable of monitoring the path and status of given service P, and then if there is a failure, then switch over to redundant destination. Next slide, please. So with that, we welcome comments and discussions, and we think that the draft is stable and kindly ask you for consider working group adoption.
Okay, Ketan is in the queue. I don't see an unmute button.
Hi.
Yeah, you're there.
Yeah.
Good.
Ketan Talaulikar, Cisco. So Greg, I understand this is the BFD discriminator attribute which is already existing, and that's defined as an optional transitive attribute. In the RFC where it was introduced, it was applicable for MVPN, but my understanding that you are expanding its use to probably all other AFIS as well here.
Yes, correct. Actually, okay. going back to the original RFC and discussion that we had, I now can better appreciate their suggestions from Jeff to make it more generic. So now, and you're right, and the scenario that being covered in original RFC for point to multi-point was different, because then for point to multi-point BFD, it is their head end advertises its discriminative value, so informing the leaves. In this case, yes, we're using existing attribute, but it's reverse. So it's a reflector advertises discriminator value that it expects ingress or packets BFD control messages to be sent with and use this value as your discriminator so that reflector demultiplexes them.
Right. So that's what I understood as well. My concern here is that this is an optional transitive, and I know probably you may be aware or not, but there has been discussion in the IDR working group about these attributes going. And in your example pictures, you showed about crossing AS borders, right?
Yes.
So I think you might want to check on this in the IDR working group to get inputs on how to prevent this information from leaking out, especially because this also applies to FE1, right? So I just wanted to bring that up here.
Okay, thank you for your comment and suggestion. Definitely will educate ourselves on that and bring it probably more. We welcome more expertise from RDR, and I guess we have Jeff ready to comment.
Jeff, are you specifically addressing this IDR comment? Okay, I'll let you go ahead of going there.
Okay, Jeff has. So Ketan's made the point excellently. The general advice IDR would give on a number of these issues is if the attribute gets attached to something that can leak into general internet or other context, what bad things can happen? So framing this specific issue here, do you really want the outside world to have your BFD discriminators? And this, what you're sort of telling people is, SBFD is a reflector technology. Reflector technologies are used for reflector attacks. So this is the danger of having, a service like SBFD, which has no authentication for echo, being advertised the outside world. Certainly, you can limit access to these technologies through firewalls. You can, make sure your domains actually are filtering things appropriately. But what you'd get as advice from the security ADs is that this is inadvertent disclosure in some cases.
Mm-hmm.
Optional transitive is unfortunately very leaky for BGP. And once you put it in there, it's sort of hard to get rid of it. So I'm not saying this is the wrong way that BGP would want to do this, but we have to address the security considerations.
Thank you, Jeff. And actually, you pointing out and highlighting this security, one of the mechanisms to mitigate security risk is use of source IP address in BFD discriminator attribute. So basically that gives the reflector way of verifying the source of BFD control messages and then protecting itself from service attacks.
Right, and that's great for control mode for SBFD, but for reflector mode, I'm not personally aware of implementations that are quite that picky yet. So this may move into additional security considerations for SBFD.
Okay, thank you.
Okay, go ahead.
Yes. Can you hear me?
Yes.
Yes. So just a quick question. In the draft it mentioned the EVPN, but I'm guessing this is also applicable to L3 VPN or probably even MVPN as well. Thank you.
Can you repeat that actually?
Well, the assumption is that EVPN is interpreted as a VPN with their BGP-based control plane. So if you're using BGP to do control of their VPN, then that technique will be applicable.
Okay. I think in the draft it mentions EVPN, so I was just mentioning that, like maybe explicitly saying IPVPN or maybe even MVPN. I guess just a variety of different, you know,
okay.
if it would be
Yeah, that's a good
applicable,
question.
I guess.
I see. Yes, maybe that clarification would be helpful because you're right. So basically that what's intended to be monitored as a destination is related to a Service 6 locator and the policy. So yeah, thank you for your suggestion. We'll make the analysis and clarify the scope of this work.
Okay, so it's Ketan and then Zhi, and then I've closed the queue because we need to move on.
Yeah, just a Ketan here, just a quick follow-up to Jeff's comments, and I'm wondering whether approach that was used for the ELC v3 isn't that some kind of something that is needed in this case as well. I'm not really sure if just putting things in the security considerations would be good enough. I'm just wondering. Yeah. Thank you.
Okay, I guess that's something that we need to talk with you as IDR experts. So thank you.
Yeah, Jidong from Huawei. Firstly, I think the motivation of this work is start from the SRv6 service, the SBFD in that case. Well, we also can generalize it to other like tier 3 VPNs. That is also possible. We may add some clarification about this in the next version. And regarding the security or the announcement scope of this feature, actually, if we use it with a VPN, in the context of the VPN, the distribution of this attribute will be constrained together with the VPN routes. So I think that is also controllable for VPN service route, right? But I agree, we need to further discuss this with IDR about the general cases. Yeah.
Of course. Thank you.
Okay, thank you.
Thanks.
So next is Fang Hong.
Hello, can you hear me?
Yes, we can hear you.
Okay. My name is Fang Hong from Huawei. Here is the co-author of this draft. Next slide, please. This document was published before IETF 112 and presented in IETF 113 and IETF 114. And there is a long thread of technical discussion on this document with Jeffrey. So thanks, Jeffrey, for the discussion. I was sent the adoption and the review request to working group after IETF 114, but not replied too long. So this time, I will choose the main points of this document to present again. Next slide, please. Long segment, the inter-AS tunnel establishment procedure which defined in RFC 6514 and RFC 6515 face some problems in IPv6 infrastructure scenario. In the regular MVP procedure of RFC 6514, LibP sends long segmented inter-AS multicast route using originator IP of the root P to fill the source S field of the NLRI, and the SBR controls the same multicast propagating between S along with the reserved path of inter-AS-AD using RDs and source AS of C-multicast NLRI to match against RD and originator IP of the corresponding intra-AS-AD. The problem is that the source S field of the same multicast NLI is 4-byte long, 4-byte length, cannot hold IPv6 originating IP in IPv6 infrastructure scenarios. Next slide, please. So here is the proposed solution. For the propagating control between ASs, SBR still control the C multicast propagating along with the reserve paths of the intra-SAD. Still use RD of C multicast NRI match against RD of the corresponding intra-SAD. The only modification is that the global administrator field of the IPv6 C multicast import RT is instead of sources field of C multicast NRI to match against the originating later IP of the corresponding interest AD. Although the IPv6 extended community carry in the semantic roots may include more than one IPv6 import RTs, there is only one which will be used by the root P to import the corresponding semantic root to its local VRF. And the only one IPv6 import RT has a characteristic that the local administrator field is non-zero, which can be used by the procedure to distinguish it from the other import RTs. It should be noted that in GTM scenarios, the local administrator field of IPv6 import RT used by root P to import the corresponding semantic root is also zero according to is also zero according to RFC 7761. So we suggest that the local administrator field of the IPv6 import RT in GTM scenario is also filled with a non-zero value, which assigned by root P through the VRF import RT carried in UMH root. So in this document. So the solution complies with the regular propagating procedure in RFC 6514 with only a lightweight modification to adapt the regular one to IPv6 infrastructure scenarios. Next slide, please. If there are only one root P for a specific multicast source, the solution is in previous slides is enough. Here is a scenario that a specific multicast source multi-homing to multi-root Ps. The long segmented inter-S C multi-root must be distinguished for each individual root Ps. There are three options. Option 1, each root P configured with distinct RD, which is recommended in RFC 6514. Option 2, each root P configured with a distinct 4-byte MVP distinguishers to use to fill the source S field of C multicast NLRI. Option 3, all if P's use the common hash algorithm to calculate the 16-byte root IPs to a 4-byte unique distinguishers to fill the source S field of C multicast NLRI. Option 2 and option 3 are used in the scenarios of Ingress P configured with a SIM RD, GTMs as an example. In this document, the source S field of C multicast NLI is renamed to root distinguisher. Next slide, please. In the process of evolution to IPv6, IPv4 and IPv6 infrastructure address will coexist in the provider's network. The following figure is an example of BGP MVP evolution to IPv6. IPv4 and IPv6 parallel BGP sessions are established, and the number of passes of this route will be doubled with each reflection. Next slide, please. So the solution is that to reduce BGP MVP route in parallel IPv4 and IPv6 BGP session networks, the following action should be taken by sender Ps. For interest IP-mask AD route, SP-mask AD route, and the NIF AD route, if the originating route IP's address field in the route is filled with the IPv6 address, it's sent to the IPv6 BGP neighbors. Otherwise, it is sent to IPv4 BGP neighbors. For inner AS IP mask AD route and source active AD route, it is sent to both IPv6 BGP labels and IPv4 BGP labels. For multicast route, if the IPv6 VF route importing extended community existing in the route is sent to the IPv6 BGP labels. Otherwise, it is sent to the IPv4 BGP labels. In the reflector routers, the part of routes which are received from IPv6 BGP label will be reflected to other IPv6 BGP labels, and the other part of the route which are received from IPv4 BGP label will be reflected to other IPv4 BGP labels. Next slide, please. Comments are welcome. We are also seeking for working group adoption. I think the issue described in the document is clear and the solution is very low. I sent adoption request after the last IETF meetings, but no response received. So I request again this time, and I wish the working group could give some response. It would be appreciated if you can give some suggestion or point out the gaps for the adoption of this document. Thank you.
Shall we go ahead?
Yeah, Jeffrey Zhang or Zhao Hui Zhang from Juniper. So indeed, we have had some discussions on the mailing list. I don't think we have reached agreement on what's the best way to address this. My understanding that you have 3 problems here in this draft. The first problem, there's another solution in another draft, which I presented in last IETF as well, and I requested for adoption. That draft covers many issues and solutions for SIMATCAS related issues. And your second problem does not seem to be IPv6 specific. So the third one is indeed IPv6 specific, and we was not covered in other drafts. But going forward, what's the best way? I think we should discuss more. But indeed, just want to mention that we also have requested for adoption for the other drafts, and I have presented last time and also followed up with the chairs with the adoption request. Thanks.
Yeah, we have a lot of adoption requests at the moment. So if you could email the unicast the chairs to bestchairs@ietf.org, that would really help actually, because I think just about every draft that gets presented, we're asking for working group adoption.
Yeah, I understand. I understand we have a queue. Yes.
Yeah. Thanks. Make sure we haven't missed anything. Okay. Thank you. Next is Swadesh, I think.
Yeah, hi, I'm Swadesh Agarwal from Cisco Systems. This is a new draft. This is for BGP extensions for SRv6 and MPLS interworking, and I'm presenting on the behalf of my authors. Next slide, please. So there's a Spring draft which describes the SRv6 and MPLS interworking architecture in the multi-domain network where each domain run SRv6 and MPLS independently. And that document already had the BGP protocol extensions. So what we are doing here is we are extracting the protocol extensions in this new draft. And this is done to independently state BGP protocol requirements and the future applicability of them for other use cases. Next slide, please. So we define a new TLB, which is called SR6 tunnel for label route. This is carried in the BGP prefix SID attribute to signal the SRv6 SID along with the MPLS label bound to the prefix in the NLRI. So SRv6 tunnel for the label route TLB signals and semantics, that is push the label signal in the NLRI and perform h.ncaps with the destination as a SRv6 SID signal in this new TLV. And this TLV is encoded exactly like SRv6 services TLV in the prefixed attribute already defined in RFC 9252 without transposition. SID behavior, which is currently defined for this TLV, is n.dtm, but in future new behaviors may come up. Next slide, please. This shows how this TLV is carried. So we have a services running from E10 to E1, which is, I'm showing here VPN services, the VPN label. And on one, we need a reachability to E10 loopback. So it's our left and the right domain are MPLS, and the middle domain is SRv6. So E10 doesn't know anything about a middle domain. It's advertised the loopback in BGPLU, regular one, with the prefix E10, implicit null, and the next hop. On the 7, what we do is we allocate this SID of DTM behavior, and we carry that SID in the prefix SID attribute of this new TLV type. And as well as we carry the MPLS label, which is bound to the prefix regularly like BGPLU. And the behavior is DTM, and it is received by node 4, and 4 will do a next hop cell and advertise to E1 as a regular BGPLU update. So now when the packet service traffic that comes on E1 would be, it's a regular encapsulation with the ABR label and the BGPLU label to E10. But on node 4, if you see what it's doing, it's pushing both it's doing a swap operation for label for the prefix for E10, that means 16010, as well as it's doing h.ncaps with the DTM behavior. And for DTM behavior, which is defined in the Spring draft, it means decapsulation and look up the label below the header in the MPLS table. So that 16010, which is from the, will carry the packet to the E10 regularly. Next slide, please. So there's another case we need to advertise SRv6 SID. And in this case, this SRv6 SID is bound to the prefix in the NLRI. Like MPLS label, this is a SID for each prefix in the NLRI. It is carried in the SAFI, it's a loop, this is of the DPM behavior, and it's carried in SAFI 4 or 1. Can you go to the next slide, please? So we can see what happens is, it's exactly same scenario, but we are advertising E10 in BGPLU, which is received by the node 7, but node 7 here allocates both the label and SRv6 SID bound to the prefix. That's important. And this document extends the BGP prefix SID attribute to carry the this SID in the SRv6 layer 3 services TLB defined in RFC 9252 with AFI 12 and the SAFI 4. TLV is encoded exactly like SRv6 services TLV in the prefix SID attribute without transposition, because we are carrying both the label and the SRv6 SID, so there's no transposition we can do. Such an update can be processed both by the legacy MPLS ABR, that means 4 could be an SRv6 capable or a legacy also. Both will take and do the relevant encapsulation. Next slide, please. Another case is, what can happen is 7 only supports the SRv6 SID bound to the prefix, so it's not allocating the label. In this case, since we can't use label SAFI 4 need a label. So what we do is we use a SAFI 1, and in that it's already defined in RFC 9252 to carry a SRv6 SID for SAFI 1 in the prefix SID attribute. We do exactly same procedures, so there's nothing new. It's just a use case showing how we can achieve in case we don't have a label on the border nodes of SRv6 domain. Next slide, please. Yeah, so we would like working group to review and provide comments. This is something which is already just a background. This is already defined it was already defined in the Spring document. We just extracted here. So it was there from last 10 versions. Here we are presenting in the BESS now as a separate document. Thank you.
Did I understand right that you are expanding what was originally the BGP prefix for SID? Just a minute, I'll get the RFC number. If you are, you should be presenting this in IDR because that's the original home on the draft.
But all the SRv6 sits, like for services, we went in the BESS. But if you wish, I can present in the IDR also.
It would be good also if it's a draft that you're modifying that's an RRC in IDR Swedish. It'd be best to present it and get some feedback.
Sure.
That way you get the review that from the original review.
Sure.
It
sure.
may be the same people, but it could be helpful.
Sure. No problem.
Jorge Rabadan, Nokia. Well, thanks for presenting this here in BESS. I think it was needed. I have just one question. Out of curiosity, so for the DPM behavior, you have two cases, either binding only the SRv6 set to the prefix or SRv6 set plus the label. I wonder, so the latter is just for migration purposes, and then the idea is to have just the...
Yeah, so if you have a greenfield SRv6 domain, border routers may not be allocating the labels. So that's the reason we gave that option. But most likely the way we feel is for the migration cases, we will use the SAFI 4 only, in which we carry both the MPLS label as well as the SRv6 set.
Okay, got it. Thank you.
Any other comments?
Thank you.
Thank you. Okay, Graham, you're on next. Sorry, I'm trying to find.
Right. Hi, can everyone hear me?
Yep. Thank you.
Okay. Hi, my name is Gian Mishra, and I'm presenting this draft, four drafts on behalf of co-authors. So the four drafts are, so the first two is related to the IPv6 only PE design. So this is IPv6 only PE design. And then the second draft is a superset of the first draft, and that's IPv6 only PE design, all SAFI. The next two draft pair is the IPv4 only PE design, and then the all SAFI. So I'll be going over all four drafts in this presentation. Next slide. So the IPv6 only PE design / all SAFI. So we had the IPv6 only PE design BCP. It was adopted in April of 2021. So the focus of this draft is a proof of concept testing BCP for vendor implementations and operators deployment. So with this, the IPv6 only PE design supports SAFI 1, 2, and 2. It was then further updated to support 1, 2, and then SAFI 128 and 129. The IPv6 only PE design, the next draft, which was mentioned about in the first slide, is called, it's the IPv6 only PE design, but it's all SAFI, so it's extensible to all SAFI. So we're taking the same concept that was applied and we're testing with the BCP use case with the original set of SAFIs, but now we're providing that extensibility with this new draft to support all SAFI. So the focus of this, so this is basically a superset of the first draft, and this one would be standards track. So the goal of this draft is to focus on the PE design, change perspective and language related to this paradigm shift. So what we're doing with both of these drafts is it's an alternative and a BCP as well as a new standard that whenever you have any type of PE-CE peering or inter-AS PE to PE peering, that now you're able to use this new paradigm shift option where you actually have a IPv6 only PE. So the PE would actually all the inter-AS PE to PE peers or PE to P peers. It would be a single v6 peer, and you would be able to carry all SAFI, and you'd still be able to support both data planes. So the v4 and v6 data plane are supported, but now you don't have two sets of peers, a set of V4 peers and a set of V6 peers. So there's a tremendous CapEx and OpEx savings, as well as the big savings with V4 address depletion. So that's a really big one with this design. Next slide. So with this design, with the IPv6 only P design, and with the IPv4 only, IPv6 only P design testing, an update that we had is we're planning to complete all the vendor testing. So Cisco, Juniper, and Nokia, we're planning to complete by the end of this year. That's really the target that we're looking at. All of the vendors support a vendor-specific nav forwarding IPv4 packets without an IPv4 address. So they all support that, and that's a critical component of the testing. And Huawei is planning to complete by 2023. Arista, we don't have an ETA, but right now we have a lot of focus on the first three, trying to get that all completed by the end of the year. Next slide. So the IPv4 only PE design. So from IETF115, and I did mention it in the other slide when I was going over the IPv6 only PE design, but we had some feedback from the working group during the IETF114 on combining drafts. So in the slide that I had just gone over with the IPv6 only PE design, the first draft had been adopted, but however, the second draft we're still progressing that draft, and we're hoping for an adoption, queuing up for adoption call. However, because the first draft had already been adopted, our thoughts are actually to progress the second draft separately and not combine the two drafts. But we would like to seek feedback from the working group, as well as chairs, on combining those two drafts, given that one draft has been adopted and the other draft is a new extensible draft, the all SAFI draft, and whether it's possible to still combine those two drafts, and it would save on cycles on working through an adoption call. So with this draft, both of these drafts are new drafts. So what I've done is I have already combined, from the feedback from IETF114, I have combined both of these drafts. So the V6 only P design, what I did was I took that draft and combined it into the new draft, the all SAFI draft. So now it's really this all SAFI draft that we would be progressing forward, that would be all encompassing. It would encompass the proof of concept testing that we'd be doing with the V4 only P design with SAFI 1, 2, 128, and 129. And then it would also encompass all SAFIs, the extensibility, as well as the next hop encoding. So with this draft, it does have an IANA code point allocation for a update on next hop encoding, and we'll go over that in the subsequent slide. Next slide. So the IPv6 only P design and V4 P design timelines and caveats. So with this is an important slide, as I wanted to kind of key in on the timeline for testing, as well as the SAFIs and what we'll be testing, and then as well as the extensibility to all the other SAFI. And that's really what the folks here just kind of making that clear. So in the IPv6 only P design, so we will be testing SAFI 1, 128, and I have a typo there, but SAFI 1, 128, and 129. Those are the three SAFIs that are being tested for both the V4 only P design and the V6 only P design. So that's the focus of what's being tested. For the IP V6 only P design, the extensibility, so here actually I have a slight typo. It's supposed to be IPv6 only P design. So the support for all SAFI, the paradigm shift, so that part of the draft, we're providing the focus on the standardization and to support all SAFI. However, we would not be testing any other SAFIs other than just the SAFI 1, 128, and 129. So I just wanted to make that clear. And then further testing related to the all SAFI is really deferred, that as operator decide to deploy SAFEs other than these first 3 SAFEs to support any of the other SAFEs, that they can work with the vendors of their choice as they're working to test and deploy any of the other SAFEs, that would be supported. The IPv6 only P design, the plan is, as I had mentioned in the other slide, that we plan to complete by the end of the year. And the IPv4 only P design testing, we plan to start after we finish the V6 only P design testing. So we want to get the V6 only P design, get that progressed to work with last call. Hopefully, once we could get all the complete testing completed, which we're on track to complete. The IPv4 only P design. So this one, so it's a new IPv6, the IPv6 only P design. It involves a new next hop encoding, which we'll be testing using the existing next hop encoding. So with this, and I have a slide that actually kind of really digs into this a little more detail, but the IPv6 only P design, so since it involves both a new next hop encoding, but we have an existing next hop encoding, what we would do is we would be following in our testing, we would be using what exists with the vendors. So whether they're using an IPv4 mapped IPv6 address or an IPv4 address, so following the RFC 5549 or 8950 next hop encoding style, we would test that, or if they support the mapped address, we would test either option. We'll work with each of the vendor development teams to get their support and agreement on the change to the RFC 5549/8950 next hop encoding style. So that would be a 4-byte IPv4 address for SAFE 1, 2, and 4. And then for SAFE 128, 129, the RD plus the RD field of 8 bytes, set to 0, a 12-byte next hop encoding standard. So it'd be a V4 address, 4-byte for 1, 2, and 4, and then 128 and 129, it would be a 12-byte in total, so including the 8-byte with an RD0. So once each vendor has developed the new next hop encoding, we would go through and test that new next hop encoding method and then progress the draft to RFC. Next slide.
Garen, can I ask you to step up a bit, please, because your 10 minutes is up now.
10 minutes is up. Okay, thank you.
Yeah, so just wrap up.
Okay, all right, thank you. Let's skip over to go down to skip to the next slide. Yeah, so I'm just going to breeze through a couple of these slides. So in this slide, we talked about the IPv4 only P design. So in this slide, it's a V4 address, but basically all the semantics of an actual dual stacking. This is providing a alternative to existing dual stacking, but now you have a V6 address, but all normal functionality that exists with your peering would still be the same. The V4, V6 forwarding, everything that would normally happen on a V4 next hop. The IPv6 only P design is a similar alternative to a dual stack peering, but now supporting all the same functionality that you would normally have with dual stacking, but now without that V4 address configured. Next slide. So in this slide, I wanted to go over the next hop encoding. So with the next hop encoding, so currently today, there is with the IPv6 next hop encoding standardization change that we're proposing in this draft. So today, you either have a IPv4 mapped IPv6 address, or there may be cases where you have a IPv4 address, so similar to the RFC 5549 or 8950 next hop encoding. So what this draft is supposed to do is really to standardize that next hop encoding, that it uses a IPv4 address and not a mapped address, and that's the goal. And
again, sorry, we've got about 30 seconds till we would announce at the start that we would do the 2-minute silence. So
thank you.
Yeah, maybe just pause here and then we'll take questions after the 2 minutes.
Okay, right. Thank you.
So we've got a few seconds to go.
All right, I'm going to wrap up and then I'll take questions. I'll go ahead and so basically in this slide,
it's like 2 seconds to go now. So
okay, okay. Well, I'll go ahead and take questions now. So thank you.
Yeah, afterwards. Yeah, thanks.
I think there's 2 people in the queue. Does anyone have any questions they want to ask? Keaton or I see 2 people in the queue.
Well, I can go. Keaton does not want to go. So I think this is a pretty good set of drafts, and it's interesting to see them progressing. I have one thing that I want you to look at, and that's the abstract. Most of the time when people write abstract, they are too abstract, so the section doesn't say much more than what the title says. I think you are making the opposite mistake. You are way too detailed, and my suggestion would actually be to move the current abstract into the introduction and then write a 10-15 line abstract per draft on a level that a technical advanced person could understand. I think you should look at RC 7322 for guiding on how to write abstracts. Thank you.
Thanks, Laura. Thank you. All right. Thank you.
Period was up because the clocks may not be synchronized. Can you hear me? Hello?
Yes, we can hear you, Keaton.
Okay, I'll. I'm sorry about that. I missed the announcement that the period was over, but I'll send it over the email. Thank you.
Hi, can you hear me? Hello, can you hear me?
Yeah, we can hear you.
Okay, so I will start my presentation now. Hi everyone, I'm Siyu from Huawei, and my co-author is Fang Hong, who is also from Huawei too. Yes. So today I'm glad to present my new version draft about the MVPN upstream designated forwarder selection. Next slide, please. Next slide, please. Hello.
Room cannot hear us, and we
Yeah,
cannot hear the.
there is an audio
There is
issue with
something broken.
the room.
There's a okay. So next slide, please.
So was it 2 minutes or 5 minutes? The silence.
No. I think Ketan, that there is an audio issue with the room now. So Matthew, I don't know if Matthew is unable to hear us, and we also can't hear him.
Okay.
So they are currently checking if there is something going wrong. Okay, let's wait to see if they can fix it.
Oh, hi. Maybe I need to check check my network and switch another laptop. So can I speak later after the next presentation?
No, it's not coming from you. It's really coming from the London location.
A London location.
Yeah. So I think it's okay for everybody who are remote, but the local guys are not able to hear us, and we are not able to hear them as well.
Stefan is right. It's a problem in London. Just wait.
Yeah, but now we can hear you, Matthew. Can you hear us? Okay, so. Okay, so Matthew is telling that they will do. Okay, they will do in person first and then catch up with remote.
I think just now, just Fang Hong has successfully displayed his presentation. So maybe I can use his laptop to try again later.
Cover the DSI scenarios. Next slide, please. So this is the background on this. This is this picture shows that hot standby mode. We have two redundant sources connected to two VTAPs there. Let me look at this. Yeah, it's so basically in the MPOS case, we have the ECI labels advertised in the SPNZ route to indicate the SPNZ route serves two purposes. One is to announce that certain flows are redundant flows. It also carries the ESI labels so that the egress PE can use to tell which flow is from which ingress PE. So in that case, the egress PEs can decide which flow to accept and which flow to discard. But in the IP-based data plane, the ESI labels are not used. So in that case, we would just use the IP source address of the outer encapsulation to tell which flow is from which ingress PE, and so that we know which flow to accept. Actually, to clarify, in the IP-based tunnel, there are two situations. One is the VXLAN, and then the other one is the Geneva, and I forgot which the other one, where it does also have the equivalence of the ESI label. So in that case, we can still use the ESI and label-based approach for that purpose. Next slide, please. So in the DSI case, we have a pair of gateways between the data center and data center interconnects. So the gateways will receive both flows from the redundant sources, and they will use the existing procedures to decide which flow the gateway should accept. And after that, the normal procedure is that only the designated forwarder of those gateways will forward the traffic into the next data center or data center interconnect. In this case, we could follow the same method that only the gateway will forward, but then we will lose the protection once we pass the gateway. And so now the new procedure here in the data center interconnect case is the gateways, regardless of the designated forwarder or not, will forward the traffic. So now, again, the egress PEs will receive duplicate flows, and now they need to decide whether to accept traffic or not. And to do that, the gateways will re-originate the SPNZ route based on the received SPNZ route to announce the redundancy case. And in case of MPLS data plane in the downstream, we can use the ESI label that is associated with that interconnect virtual segment. But here, the one difference is that those gateways, they should have different ESI labels for the same virtual Ethernet segment, so that the downstream PEs or gateways can use to determine which flows are from which gateway, and then decide which flows to accept. Again, and that's the assuming when the downstream segment downstream is the MPLS data plane or Geneva or SRv6 data plane. But for other scenarios like VXLAN, we will use the source address of the gateways in the outer encapsulation to determine the flow and to determine whether we accept or not. There is also another situation where even when you don't have the true source redundancy, then the fact that the both gateways receive the single flow, they can still decide to, based on the operator's choice, they can all send traffic to the downstream, whether it's a designated forward or not. That's what we call gateway introduced flow redundancy. Similarly, as long as all the gateways and all the PEs in the domain act the same, follow the same procedure, the downstream PEs or gateways, they can know that
there is this redundancy flow from the gateway so that they can pick which flow to accept and which flow to drop. Next slide, please. So we have described the procedures in the draft, but we need to add more details on the normative part of the draft. We will add more details to the draft. And in the meantime, we request feedbacks and comments from the working group. Thanks.
Any comments? Do not see anyone in the queue. Thank you. So, see, if you're still there, we'll go back to you now. I think it should be working again now.
Okay. Okay, let's start. Hi, everyone. I'm Siyu from Huawei, and Fang Hong is my co-author, and I'm glad to present my new version draft about the MVP and upstream designated forwarder selection. So previously, we have presented a draft in the IETF 113 and 114. So next slide, please. So when there are multiple PEs in ingress site, we need to designate one as primary forwarder to forward the traffic to the leaf PE. Another PE is chosen as a standby designated forwarder as a backup. But primary and standby PE receive traffic from both primary and secondary PE receive the traffic from multicast source. In warm root standby scenario, only primary PE will forward traffic to leaf PE. In IFC 1926, leaf PE needs to select primary and standby PE. However, problems such as inconsistency between the root and leaf PE will result in slow fail over time. Therefore, we propose the idea that the ingress PE should designate forwarders themselves to avoid the inconsistency. Leaf PE will also accept all traffic from root PEs. So this time, instead of the VRRP method in previous version, we propose our new systematic and endogenous procedures for ingress, DF election, and fast failover. We also introduce relevant attribute and community. Next slide, please. So since the ingress PE will negotiate about the IDF role, we propose two negotiation modes here, the passive and the active one. In passive mode, CE will decide which route will forward traffic to leaf PE. The interfaces that are multi-home CE to PE are combined in Ether trunk interface. The root PEs will be bundled together using the multi-chases protocol. While in active mode, the routers inside the CE network and PEs inside the ingress site will be connected using layer 3 interfaces. The ingress PE this time are independent routers. Traffic from multicast source will be forwarded to all ingress PEs. Therefore, the IDF election and negotiation need to be done actively inside the ingress site. Next slide, please. So we define a new community called IDF Negotiation Community. It is carried in the upstream multicast hope routes, and its value will be allocated from the BGP well-known communities registry for each negotiation mode. The UMH routes will be delivered to the root PEs and leaf PEs. For root PE, it is used to notify other PEs that this PE will participate in the IDF election. And leaf PE will regard the community as a symbol to install the corresponding P tunnel routed from the root PE into the leaf PE's anycast RPF checklist. The BFD discriminator attribute is firstly defined in IFC 9026, and we reuses the format. And we add a new BFD mode type called unicast BFD session type. The value is suggested to be 2. The BFD discriminator attribute needs to carry a mandatory source IP TLV this time. The IP address of this IPTLV will be used to establish the BFD session for failure detection. Next slide, please. So let me introduce the election procedure in detail. Root PEs firstly originates the UMH roots, and the negotiation community and the BFD discriminator attribute are carried inside. The IP address of the source IPTLV in the BFD discriminator attribute is the RPF interface of the root PE, as shown in the figure. According to the negotiation community, leaf PE will send distinct C multicast routes to each root PE, and P tunnel are installed, and traffic from those installed P tunnels will be valid and not be dropped. Next slide, please. So the root distinguishers of each root PE for the same MVPN are suggested to be distinct. When the UMH route to client multicast source are advertised to each root PE, they will know each other's originator IP addresses. The key procedure here is to generate an ordered list of these IP addresses in ascending order, just as shown in the table. Firstly, if for different scenarios, two methods are defined here. Firstly, if all C groups uses the same primary and standby IDF, the election occurs upon receiving all the UMH routes of other PEs. According to each PE's position within the list, they will be given different indexes. PE have index 0 will be the primary IDF, and with index 1 will be the standby PE. So next slide, please. The second method is for the load balancing scenario. This time, different groups can use different PE as their IDF, and one C group will have different PE as primary and standby PE. The order list is used here also, but with different algorithms. The election occurs upon receiving C multicast join of the corresponding group from leaf PE. P with index I will be the IDF if I equals to group mode M. After the IDF is elected, a new ordered list without IDF PE will be used to calculate the standby PE. And the equation becomes J equals to group mode N-1. And PE with index J would be the standby IDF. Next slide, please. So we have elected our primary and standby IDF with above procedures. Another very important function of warm root standby scenario is to detect the failure of the primary IDF and perform fast failover. This time, we mainly introduce our endogenous method for active mode. In order to detect the failure of the primary IDF, the standby IDF need to initialize a BFD session. The destination IP address of the session is the IPF interface of the primary IDF. Therefore, when the IDF device or its client-facing link is down, the standby P will immediately notice that and take over the primary IDF role to forward the traffic. When the traffic arrives at leaf PE, it will not be dropped because the P tunnel has already been installed into its Anycast RPF list. Next slide, please. So finally, the data forwarding behavior of the root and leaf PEs are discussed. In active mode, if there are local receivers at the ingress side, they can receive traffic directly from the corresponding root PEs because all root PEs can receive traffic. While in a passive mode, only one of the root PE can receive traffic. Therefore, the PE with local receivers will install P tunnel towards the IDF. The traffic will be forwarded through the P tunnel, and it will only be forwarded towards the local receivers to avoid the traffic loop. As for the leaf PEs, they accept the traffic from each PE, but at a time, there will be only one traffic that's forwarded from the source. Therefore, they can accept the traffic from the standby IDF without latency. So next slide, please. So that's all for my presentation. So we welcome any comments and discussion, and thank you. So if you have any question, you can ask.
Okay, thanks very much. Let's see. I think we should move ahead with the final presentation, which is Wenlin. Are you there? You can try. Okay. Let me just.
So this is a proposal for a new extended community to advertise group-based policy ID. Next slide, please. So for EVPN VXLAN, there is this concept of group-based policy, so that the ingress PEs can signal to the egress PE in the data packet on what group policy to be applied at the egress when the traffic arrives there. But it could be that the ingress send the traffic to the egress, and after the egress applies the policy that is signaled in the packet itself, then the decision is to drop the packet after we have got the packet to the egress. We want to avoid that situation. Next slide, please. So we want to apply the policy on the ingress instead of getting the traffic to the egress and then dropped. Next slide, please. So this is the proposed extended community that encodes the group policy ID. It's a non-transitive OPEC extended community. We encode the policy ID, which is a 16 bits value there. I think we already got a type and subtype allocated from Diana. This can be carried by EVPN type 2, type 5, and type 3 routes in control plane, so that the ingress nodes knows that for which traffic we will apply the policy on the ingress side. Next slide, please. So the DCI procedures will need to be added. We also request feedbacks from the working group.
Okay.
Jorge Rabada, Nokia. Yeah, the draft is pretty clear and straightforward. My question is more about the group policy draft, which is a long time expired. So is the intent to resurrect it?
I don't know the plan about that draft, but apparently we have some customer use cases that they wanted to do this kind of things. I think I'll need to ask Wen and John to talk about the plan for that draft.
Okay.
Yeah, I think I agree with Jorge. This is a fair point. There is no real point to create something at the control plane and try to standardize it if the data plane is not standardized.
Yeah.
So we may have to move forward the data plane.
The other comment, and probably Matthew can clarify, but my understanding was that the consensus was not to extend a VXLAN, right? But to, if there is an extension to do it probably in Geneva or VXLAN GPE, right? But not VXLAN per se.
Yeah, we didn't. So the VXLAN RFC anyway went through on the individual track. Mm-hmm. Certainly from an NVO3 perspective, the preference would definitely be to go for and use Geneva. That's the kind of IETF direction.
Okay.
I just realized that this draft is about using ingress policy enforcement to replace the egress policy replacement. So
it does not mean that we are reviving that group-based policy draft that's actually put into the policy ID into the VXLAN package itself. We're proposing a different solution.
Okay, so what you signal from the egress PE to the ingress is not used in the data path.
Right. This is an alternative solution to that. It's better option. Yeah.
Okay, I totally missed it. All right, thank you.
Yeah.
I think one last comment from Wenlin is in the queue. No, she disappeared. Okay, all right. Thanks very much, everyone, and I think that's it. I muted everybody, but then it didn't give me an unmute button. I just stuck with everybody muted.
Yeah, and strange part, Ketan was saying that in background they were talking.
I could see that. Yeah, I could see it picking them up, but there's nothing going through.
Yeah.
Strange.
Sometimes technology.
Actually, generally it works super well. Right.
I think he's fun. Thank you.